Good morning, good afternoon, good evening, everyone. Thank you so much for joining today's webinar. And today we have Seth Grover, our today's webinar speaker. He is cybersecurity researcher at Idaho National Lab and will be presenting on Zeek file extraction and automating malware analysis. So welcome, Seth, and thank you so much for doing it. And take it away.
Thank you, Fatima. Yep, I'm Seth Grover. I'm a cybersecurity researcher here at the Idaho National Lab, and I have been in this position for about 7 years. Prior to that, I worked in private industry. My education background is computer science, and then kind of in my first job out of college, I landed in a development position working on IDS, IPS, SIEM, and I've kind of been in that area for about the last 20 years. And I'm native to sunny Idaho. Right now we're getting into winter, so that's always fun. And personally, my wife and I have 4 daughters and a dog and a cat, and that's about it for me. So I'm happy to be here, talk to you guys. A lot of you probably in the Zeek world have seen me around Slack as well and stuff. So that's always a place you can find me. Well, I'm just going to jump right into it. I'm going to share my screen here, and we'll talk a little bit about what I've prepared for you today. Okay, hopefully you guys can see my window here. So this presentation is going to be, I think, maybe a little less technical than some of them we've had, a little more kind of like a use case. So we're not going to be like, although we'll be doing a little bit of Zeek, like in some Zeek scripting and stuff, like more, I just kind of wanted to show how, in our one use case, we have taken the Zeek file extraction feature and used it kind of as the source of I think a lot of really cool stuff in what we do as I develop software and tools and stuff here at Idaho National Lab. I'll be dropping my slides in the Slack here in a little bit as soon as this is done. So if anyone wants a copy of them or whatever, I can give it to you after the fact. And I'll be sure to try to leave some time for questions at the end. Okay. Perfect. I was just checking with my coworker here that that sharing was working correctly. So let's get started. This is what the Zeek files.log documentation says about the file analysis framework. One of Zeek's powerful features is the ability to extract content from network traffic and write it to disk as a file via its file analysis framework. And I wholeheartedly agree with that description. Like, I think the file analysis framework is a really powerful capability that Zeek gives us. And there's a lot of really good documentation for this. So like, if all of y'all want to know more about this, of course, like as always, the place to go is the Zeek documentation. And you can learn about the different events and things that happen in the lifetime of a file and how it hooks into the file analysis framework and some of the other cool things you can do and built-in analyzers and things like that. So certainly a lot of good documentation there to help you figure out what that's all about. As it says here, like there are built-in analyzers or some protocols, some of the built-in protocols, analyzers for Zeek have that file, hook that file analysis framework just kind of automatically. And so, I mean, kind of just the ones you would expect, things like FTP and HTTP, SMB, SMTP, and then some of the other ones. Some of the other ones here, like RDP, SSL, Kerberos, stuff like that, it's more file transfers that are involved with like a handshake or a certificate and not like some big blob usually. But of course, like what this gives us is it gives us just that much more visibility into our traffic. So as I've got these, by the way, these are actors. This is a dramatization. These are not real necessarily Zeek users, but this is the confusion without the file analysis, and then this extreme excitement here with the file analysis. One of the good things about putting a presentation together for other geeks like me is I can put memes in my presentation. So there will be a few of those today. So of course, just like everything else in Zeek, like just kind of a little more background about the file analysis framework. It's all very hookable and extensible. So as you develop additional parsers, um, whether it be in the new hotness, which is spicy, or in BinPack, more legacy stuff, like it's very easy to hook the file analysis framework and declare handlers for file start, file data, file close, and then like all those other benefits of the file analysis framework you just kind of automatically get by defining like where in your protocol is a file. And like, what is a file? Well, if you're a Linux nerd like me, like, I mean, everything is a file, right? Whether or not it's actually kind of what you would consider traditionally a file, Zeek really doesn't care. If it's some object or some blob or something that has a data stream, if you want to hook the file analysis framework, you can totally do that. One of our industrial control systems parsers, I want to say maybe our S7 com parser, um, like it has a file. It hooks into the file analysis framework, and the things that it registers there, they're more like I think like logic for PLCs, that sort of thing, than what I would really consider like a quote unquote file. But if it's something that has that's representable as a stream of bytes that you want to do some of this analysis on, whether it's just like the built-in stuff like um, hashes or entropy, or whether it's like you want to extract it and run it through other tools, which is kind of the use case that I'll show today, then it's that's available too. And of course, there's built-in, sorry, not built-in, there's plugins you can install using the Zeek Package Manager to get more capabilities that extend that file analysis capabilities. So a couple of them that I have listed here, right? There's the Zeek Spicy Zip, which is a zip analyzer and will be able to extract zip files and kind of feed them back into the top of the file analyzer so you can see inside those archives. There's one that I think Seth Hall maybe is the original author of, but it's the Zeek XOR exe plugin, which is for deobfuscating XOR obfuscated executable files. And so then you can do portable executable analysis on those. There are analyzers for specific file formats. So in addition to just like noticing or registering that there is a protocol in traffic, or sorry, that there is a file in the traffic, you can add analyzers for specific MIME types and then like pull more stuff out of them. So there's all sorts of stuff you can do with the file analysis framework. Kind of how I will couch this discussion today is in the context of Malcolm. Malcolm is an open source project that I've been developing here basically since I arrived at the National Lab. And it is a tool suite for network security monitoring that began just kind of as an experiment to get bro logs into Moloch, or in today's parlance, Zeek logs into Archime, and then kind of expanded and grew and has kind of picked up steam since then. So kind of what we're talking about today is how we in Malcolm leverage that file extraction, or sometimes I call it carving capability, and pull certain files out and then automate those files into a pipeline to know more about them by running scanners, other tools like Yara and ClamAV and Kappa, etc., on those files to then feed those back into our database and kind of cross-reference the results of these scanners against these files with your network traffic. Of course, like this isn't a commercial, really. Like anything I'm talking about today, I mean, aside from the fact that it's open source, like it would be very easily adaptable to, I think, other workflows. So like some of the scripting source that I'll show, which is again pretty light on the actual scripting, but like it's all available at the Malcolm source code, and then you can go find it yourself. So here I am at the Malcolm documentation page at sysadgov.github.io/Malcolm. You could go follow it to the GitHub page and go down to Zeek and config, and like these files here are the Zeek scripts that I'll be talking about today. So this isn't like a drink your Ovaltine kind of commercial for Malcolm, really. It's just like, here's how we're doing it in this, but it would be easily adaptable to other use cases as well. Kind of just to like zoom in on where we're at in the data pipeline, at least as far as Malcolm or another like NSM would go. Your network traffic comes in. For us, that traffic gets split three ways and goes into Archime and Suricata, and then of course Zeek. And then that is where this file extraction, this carving happens. And then we do that scanning based on that. And then that feeds back into Logstash pipeline where it's normalized and enriched and like apples and apples correlated and stuff. And then of course that's searchable via the we throw it into an open search or an Elasticsearch database, but whatever the next part of the pipeline is after those results from those scanners get analyzed. So kind of the first question that we present an end user with in this use case is, what kind of files do you want to extract? Because you can get, you can get as specific as you want with it. You can extract all files. You can not extract any files. You can do files with certain MIME types, etc. And so these are kind of like the different categories that we present the user with when they're configuring this file extraction for Zeek. Basically kind of the ones of interest are, I even have like a whole different slide for this. So what are the trade-offs? The trade-offs obviously are like, how much disk space / retention do I want of the files that I'm extracting versus, and like how much processing do I want it to take? Because if I'm extracting all these files, I have to look at them or do something with them, or at the very least save them to disk. Versus so it's just that usual kind of like, where do we find the sweet spot between everything and nothing. And we have a couple of different modes that we present to the user that they can choose. One of them is like obviously all observed files, and that's just like extract everything. Every file type we see, we're going to extract it and then look at it. That I sometimes think is overkill, and we have, I think, some ways to kind of, if you want really everything but not quite the whole fire hose, we have some ways we can show you to like cut that set down a little bit. The second one that we offer the option for is like known file types, and basically that is file types for which Zeek can establish a MIME type. So sometimes Zeek can see this is a file, but like it doesn't necessarily know what the MIME type of that file is. So that would be known files. And then kind of like a further restriction of that would be files where we're mapping MIME types to known file extensions. So in our source code here, like I've got in this extractor params.zeek, I've got this big map of string to string that maps a whole bunch of MIME types. And this is a list, I think I got the comment here of how I pulled this list. I pulled it from Apache's HTTPD project, all this big list of MIME types, and then mapped it to file extensions. And so like this probably isn't exhaustive. There's more than maybe, I don't know, 920 or whatever MIME types, but this is, I think, a lot of the common ones. And I'm mapping those so like, XDOS executable maps to .exe or whatever. And then it just allows us to save it with the file extension that would be expected by the end user. And then finally, like one that I oftentimes find us turning on is maps except common plain text files. So a lot of the time, I think a big piece of the fire hose that you see when extracting files is like really small or like kind of single use like operational types of files that don't really give you anything beyond what the Zeek logs themselves give you. So for example, X509 certificates, like really, I have found like I don't think it's super useful to extract that and save it as a file, because I have the x509.log that really gives me all that information anyway. Or another example, we were in an engagement one time that the customer had these like security cameras, and every single time the security camera like incremented itself like 1 degree to scan a little bit, like to move left and right, it would be controlled by some controller that was like posting a tiny text file that was like move 1 degree to the right, right? And so like a lot of those, it's kind of like I don't really want to see maybe everything when it comes to these plain text files, but I want to see almost everything else. And so that's what this file type or this kind of list is for. And you'll see here in this same extractor params.zeek that I was showing you a minute ago, like this is just kind of this subset of file MIME types that like I don't care for. And you could expand that to include other types if you know if you don't want to see images or if you don't want to see whatever like that, you could include your own MIME types and redefine that as being whatever you want. And then of course, like there's a couple of other parameters that do go into it. Actually, let me not get ahead of myself. Oh yeah, we're not quite to that point yet. The next part is interesting, and this is very subjective. This is me just like sticking my finger up and saying like, what do I think is interesting? So we give the option for a subset of all of the MIME types we know about, and we say these are interesting ones. And interesting to one man might be different from what is interesting to another. And so it's like, well, we've defined that as file types of common attack vectors, meaning maybe they're like executables or PowerShell scripts or .jar files or .zip files or documents that could have or spreadsheets or whatever that could have like macros in them. So like again, this is very subjective, and like if you look at this. So actually going back to my source code, if you want to take a look at this, there's extractor override interesting.zeek. And all this really does is it just redefs that map of my MIME types to include just the subset of ones that I've considered interesting. And if you're like, Seth, I see this list and you're missing some very important file types that could be interesting from a security standpoint, let me know. Like hit me up in Slack and be like, hey, you should add this one. Because again, this was just me kind of taking a stab at it. And I think there certainly includes some good ones, but maybe we could improve it. So that's one that I find myself using a lot is like, hey, I don't care about, certainly like any file type could be of interest. You could do, like, what's it called, like stenography or whatever, right? I don't think that's the term, but where you put you embed things or you use like unrelated file types to do exfiltration. And so certainly like if you were really wanted to be paranoid about it, you could grab every file type. But a lot of the times the things that we're interested in are archives or PDFs or zip files or scripting and that sort of thing. And so that's what this interesting list is. So it's kind of a good spot between, I would say most people will probably gravitate in between this everything except plain text files or the interesting ones, um, unless they really want to get like the entire kitchen sink and everything, and then they'll either do everything or they'll do kind of a choose your own adventure where they pick and choose. We give them that option as well to pick and choose from that giant list of MIME types, like specifically which ones they want, and then just extract those ones. So like once you've decided which files you're going to sniff, the next part is like, okay, well, what do we do with it? So going back to our source code, our scripting, we have this extractor.zeek, and this is this is less than 50 lines, but this is really just like the basic logic that says, okay, what are we going to do with it? Since we deploy everything in Docker, we control basically all of the functionality of Zeek with environment variables. So here at the top, and this works for all sorts of other things, not just file extraction stuff, right? But we have certain environment variables that are defined, and we say, hey, as long as that environment variable is not blank, then that's the value that I want for the extractor mode, or for the max size of the file to extract, or for where I want that file to be saved. Otherwise, default to some default, right? To some known size. So like I think we default to what is this, like 100 and I don't know, 128 megabytes or whatever of file size. But like if you wanted to extract bigger ones or whatever, like you could totally do that. And we do that with environment variables. So yeah, we specify there's this file sniff event. And this file sniff event is basically the event that gets triggered. And if you want to know more about it, that's awesome because you can go to the documentation, file sniff, and click on that. And it tells you all about what the file sniff event is, which is provide all metadata that has been inferred about a particular file from inspection of the initial content seen at the beginning of the file. In other words, like when a file is detected and we think we know what its MIME type is, Zeek thinks it knows what kind of a file it is, this is where you hook that. And so this is where we kind of make this decision as, is this a file we want to extract or is this not a file we want to extract? And so we do kind of some logic here where we say, what's the mode? And depending on the mode, is it in the selected list of MIME types that we care about, whether it's the interesting one or the map one or the not common text one. And then, if it is, well, okay, what do we want to do with it? We want to extract it. We want to save it to disk because we're going to do initial analysis on this file. So basically the rest of this is just kind of building a file name. All of this code here is basically saying, hey, if we can, get a file extension from that mapping that we came up with before, pull the file timestamp out of this last active timestamp that is associated with that file handle in Zeek, and then fall back to the current network time if that is not available. And then if possible, extract the UIDs for that connection. And so what we do is we build this file name based on kind of these 5 things. The source of the file, which is, actually my slide might say this better. Yeah, okay. The source of the file, which is like HTTP, FTP, SMTP, whatever, right? The protocol, more or less, or the plugin that has caused it to extract that file. The FUID, and the Zeek connection UID, and then a timestamp, and then that file extension. So that's how we save our files for extraction, because it allows us to kind of get just with that file name, actually some information about that file for later. And we can use those things like the UIDs and the FUIDs as pivots into looking at our data, the other logs, which is the point of those, right? Cool. So we've decided what files we needed. Hide the Pain Herald helped us with that. We have sniffed the files and we've determined what what the file name and stuff is going to be. And we've actually did the most important part, which is this last line here in this add analyzer. This last line here, I'm glad I didn't skip over it, says, hey, for this file handle, we want to extract this file, and here's the file name, and here's the max file size. Like, don't extract more than that. And that's what actually tells Zeek to extract it to disk. So now that we've extracted it, what do we do? Well, what we do in Malcolm is we take those files and they get dropped into that extracted files directory, or directories. If you're doing it with like Zeek CTL, there might be a directory per worker. We have a watchdog process that essentially uses like iNotify, and it watches those directories for files to be written and closed. And we publish those to a 0MQ topic that is then picked up by these other scanners that they subscribe to it, and they get this notification that says, hey, you have a new file to scan. What do you want to do about it? And we have built into Malcolm today these 4 open source file scanning. Well, I should say open source asterisks because of the last one. That one's more API based than it is like an open source tool. But first is ClamAV. I'm sure people are probably familiar with what that is. That is an open source antivirus toolkit. We have Yara, and Yara is a great tool for just arbitrary signature based detection on files. And we have a default rule set that we curate, or user provided rules. If you have custom rules, you can drop those in. We have a scanner called Kappa by, I think, Mandiant or FireEye, or whichever one bought whichever other one. It is a capabilities analyzer for executable files, which is really cool. So it allows you to do some executable file analysis without actually doing dynamic analysis and like having to sandbox the file. So it can look at an exe and tell you like, does this exe does it open a network connection? Does it attempt to detect if it's in a virtual machine? Does it try to obfuscate certain resources that are in that. So some of these files will trim that list of MIME types down even further. For example, we only send executables into Kappa because it doesn't make sense for us to send, .txt or like .jpeg files into an executable capabilities analyzer. And then finally, the last option we have is if folks are running Malcolm with an internet connection, they're not doing it like air gapped, and they have a API key that they can put in the configuration. We can then take the hashes that are associated with those files that is one of the Zeek analyzers that happens for extracted files, if you should turn that option on. And then those hashes will get submitted to VirusTotal, and they'll come back and say, hey, it triggered whatever thing that VirusTotal says it triggered. Okay, so now kind of the more fun part is like, where do we see this? Where does this show up in the dialog? So in Malcolm, we have a couple of different places that you can see the reports of these file scanners. Essentially what we do with it is, and this is actually the part where I'm sure there's somebody in the Slack or watching this presentation or something that's like, Seth, you're doing it the hard way. You could like probably plug in to the Zeek input framework or something like that. And like, you wouldn't have to have this external process. You could just pipe it back into Zeek. Like, if so, I'm the kind of person who likes to learn from people who are smarter than me. So if I'm describing this and you're like, that's a dumb way to do it, absolutely hit me up on Slack and tell me how I can do it better. But essentially what we do is we take those reports from those file scanners and we feed them back into our data pipeline. Really what I do is I create kind of this fakey looking signatures.log that uses the Zeek file format and creates the same fields as like a signatures.log that Zeek would create, only I'm like the zombie one that I'm not actually Zeek. I did it totally just kind of myself. And but it gets fed into that same pipeline and it gets parsed out the same as all of our other Zeek logs and end up in the dashboards that we have that are populated by this OpenSearch and Elasticsearch databases, whichever you happen to be using. And the main ones that we want to talk about are our files dashboard and our signatures dashboard. So I'll tab over to an actual running instance of Malcolm. Here we are, and we would go into our dashboards. So here, I'll actually just start from the top. We click on dashboards, and this is kind of our primary analysis front end. Well, one of two. Dashboards is one, and Archemy is the other. And I'll extend my time span out to like a long time ago since we're using historical data here. And we have here under our general network logs dashboards, we have the files dashboard. So all of these files that get scanned by the Zeek file analyzer are going to show up here. And we can see the source of those files. Basically, more or less, that boils down to which protocol it came out of. Although if you're using one of the extensions like the spicy zip extension or the XOR decryption extension, that shows up as a source as well. And then it's got all the other stuff you would expect: MIME type, file size, paths, as long as it can figure out what the paths are, etc. The nice thing about this, and like this is why these fields exist, of course, is you can use those UID values as pivots into all your other Zeek logs. So if I want to know about some emailed files, right, I could filter by the source of SMTP and pick, a zip file as the MIME type, narrow my list down. Once I've identified that event ID, the connection ID, or that FUID, that file unique identifier, right? I could then filter on that and say, you know what, I just want to filter on I'll filter on the connection UID, right? Come back up here, pin that filter, remove these other ones, and then drill back up to my dashboard. And I can see, okay, this file, this .zip file that was sent over SMTP, it triggered something in weird.log and in files.log and in con.log, right? And then I can use that and I can pivot over to like weird and see what it is that's weird about this thing, SMTP mail transaction invalid, right? So those UIDs can be really useful as a pivoting source from that extracted file, from that scanned file into other dashboards. The other kind of side of the coin for us is the signatures dashboard. And this is where those triggers for all of those scanners, the CLAM IV, Yara, Kappa, VirusTotal, etc., those signatures come out here and get manifested in a signatures.log, and then we can find out more about them here. So if I wanted to know about the antivirus signatures that triggered, I could go to CLAM AV, and I could, find out that this I don't know, whatever, like Gina Pass Trojan triggered, and I can click on that, and then just like same pattern, right? Maybe I filter on that FUID for that file, and remove my other filters, pin that filter, and I can see that file triggered not only that win.trojan Gina Pass, but it also came up some stuff out of Kappa, right? And then I use that to pivot out to other dashboards. This one came from a Samba connection, and I've got some information that I can see in notices about it. So what is it about that I can see in notices, right? So that kind of pivoting back and forth between the signatures that came out of our scanners and then the UID/FUID that came out from Zeek allows us to really get a good picture of like this file, really what's the context of it? What's the source? What's the destination? What signatures or whatever triggered in our antivirus, and like, what other things happen surrounding this file. The one other thing that we do is we preserve certain files should you ask for it, so that you can take those files then and do additional analysis of them. So maybe you've got someone in-house that is like a reverse engineer, and you're reverse engineering malware, or you want to load it up in strings or Ghidra or some other tool that does unpacking of files. You can totally do that. So you can preserve files. Basically, we give you three options for that: either none, all, or quarantined. This isn't actually a function of Zeek itself. This is more what our post-processing of these files does, whether like it deletes the file or leaves it on disk for a certain amount of time. We also then give the user a couple of different ways to access those files. We have an extracted files download part of our files dashboard here. So if I go to files, I've still got this filter on, right? I can see here it says, hey, here's the download link to that extracted file. And you'll see it's named the way we named it earlier: SMB, FUID, ZQID, and then the timestamp. I can click on that, and it downloads that file for me. Now you'll notice here it's actually got a .zip extension, and we'll talk about that in a second. We also just provide an interface where the user can browse the files that have been quarantined or preserved. This is essentially just like a big list of all the files that have been extracted, their MIME types, their sizes, the data source, and then their hyperlinks back into dashboards. So I could click on this UID or this FUID to jump back over into dashboards and examine that. Now, so the only danger about this is you don't want to be the guy who infects like your operations whole like system or whatever because you downloaded a file that was carved out of Zeek file traffic that is live malware, right? Like, and some of these could be. And so you want to be careful about that. You want to be careful about that, more careful than I was about adding an extra tab into my slide right here. So what we allow the user to do is to, in this web interface that is used for downloading these files, we allow them to optionally zip and/or encrypt those files. So you'll notice when I downloaded that file, it saved it with this .zip file extension. And so like, here's my file. Which one was the last one I downloaded? It was this Samba one, right? So I can see that file is a zip archive data, at least v2.0 to extract, compression method AES encrypted. And for me to unpack that file, it's going to ask me for a password. And that's just kind of an extra layer of like, not really security, but like an extra seatbelt to prevent you from infecting yourself with files that you've extracted from Zeek. So what else do we have to go forwards with this kind of feature in the future? What other things could we do? A couple of things that we're looking at. These are not like promises yet, but they're things that we're talking about doing in our roadmap. Number one is replacing our existing file processing pipeline with Strelka. Strelka is a super cool uh, framework that's actually developed by Target of all things. And it is kind of a more extensible file scanning / analysis pipeline. We think that actually it would be a better kind of more modular drop-in than the Python scripting that I'm doing today that handles these files and the file scanning. So sometime in the next year, we may see ourselves moving away from our kind of homegrown pipeline there and replacing that with something like Strelka. Another option that we have as a possibility, the Canadian Cyber Center has developed a really neat tool called assembly line. And it is a more kind of full-featured, a little bit beefier, more scalable file scanning pipeline. It's a little too beefy for us to like embed into Malcolm, but we're looking at adding an API extension that would allow us to take these files that we extract from Zeek, ship them off to assembly line, and it can do actually a lot of stuff, like even do like malware detonation, spin up like a Windows VM and detonate the malware in it, and then see what it tries to do. That's really, really cool. And so we may get there and say, hey, if you got an assembly line instance that you want us to ship files off to, we could support that. So these are possibilities, things that we're looking about doing maybe in the next year or so. So that's it. That's kind of just our little like, here's how we use file extraction to get some really easy to get data out of the files that are transferred across your network. Again, like this wasn't some revolutionary, groundbreaking, new patentable idea. It's taking the files that Zeek gives you and throwing them at these other things that like to look at files. But it is a use case for us that has been really productive and has allowed analysts and people using our open source project uh, to get information about the kinds of files that you might find transferred across the network via HTTP or SMB or SMTP or whatever it is. So that being said, I will, if we've got any questions, I think I went a little longer than I promised Fatima I would, but I'm happy to answer any questions should there be any, or you can always hit me up in the Slack and ask me questions there as well.
Thank you so much, Seth, for the wonderful presentation. And yeah, let's open up for questions. We have a couple minutes to accommodate some questions if people have. And let's see if we get any questions. Okay, looks like I don't see any raised hands or any questions in the chat. So looks like that there are no questions. So thanks again, Seth, for, oh, there is one. Okay, cool. Let me allow Tim to talk.
Seth, can you hear me?
Yes, I can. Thanks.
Okay. Seth, you, from what I've read in the past, sort of focused Malcolm on the critical infrastructure. And since you've been using the Zeek file extractor, are you seeing the requirements change any from the targeted market of critical infrastructure, or do you have many use cases where critical infrastructure stakeholders are concerned about file extraction? And if so, what kind?
Great question. And this is actually one of the reasons that we're looking um, to move some of our framework into some of these slightly more extensible and maybe more capable file scanning pipelines. One of the areas that we would really like to do a lot with, but we're not yet, is in trying to detect and then do analysis of like firmware updates or like logic changes that are pushed to industrial devices. We have some of that that's being done. Like I said, I know Stephen Kleinheider, the author of our S7Com protocol, did hook into the S7Com, did hook into the file analysis pipeline for these uploads and downloads that happen with S7Com. But we're not really like, we don't have really analytics based on that yet, other than just that here's some data that was pushed as an update or whatever, but not like doing anything with that data. We have an Omron Fins parser that's going to be released sometime in probably the next month. I know it has the concept of file transfers as well, and I know the developer of that is using the file extraction framework as part of that. More though, I would say like I think more we see use from actual customers in kind of the IT side / the generic protocol side of the house. You know, a protocol like HTTP, hopefully less so SMB, like those things are, you know, traditionally thought of as being more on the IT side of the house, but certainly they exist on the OT side as well. You know, HTTP is used in management of a lot of different types of devices. And so you will see like requests and responses show up in an OT network over protocols like HTTP, or sometimes things that are being done by historians. So I think that, you know, long story short, like there's more for us to do there, but we have seen a little bit. But mostly I think we see those kinds of parts of analysis being done on the IT side before it kind of reaches the OT part of the network.
Okay. All right.
Great question. Thank you.
You're so welcome. One of the file types that Zeek has been Robin has been working on for years is the capability of having a Zeek agent. And that really becomes a log file for Zeek to analyze, such that you're analyzing who is the user and what sort of a network connection, and making a determination of the integrity of that connection. And do you see that that sort of file analysis as a point of interest to the critical infrastructure, or is that, from your experience, just out of scope?
I think certainly in some types of devices found in critical infrastructure, that is very much of interest. Like we do some similar things in Malcolm where, you know, there are, you know, for example, there are like Windows boxes or whatever, or Linux boxes that are not low level industrial devices, but exist as HMIs or historians or whatever. And,
Right.
you know, we're grabbing, Malcolm can accept like Windows event logs or you know, take syslog or whatever from those devices. So those aren't technically like network data. It's more host-based data, kind of like what you're talking about. So I think that the interest really would be there, depending on kind of I guess what hooks and stuff are available, or what kind of logging would come out of that agent, whether it's, you know, at the, you know, I don't really foresee us being able to like run these scanners habitating with the agent. It would be more like, you know, file names and maybe file hashes and things like that. But even that is useful in the terms of feeding that information back into something like this and enriching what we're getting in these dashboards. So that's a cool idea. Thank you.
Okay. All right. Thanks for your presentation.
Yeah, absolutely. Okay, y'all can hit me up on Slack. Like you can find me that way, or you can get us on the discussion board over on the Malcolm GitHub. And if there's other discussions or ideas or suggestions that you might have on this topic, I'm happy to entertain them anytime. So I really appreciate the time that I've had to visit with you guys today.
Thank you so much, Seth. Looks like we don't have any other questions, so we can just wrap this webinar up. So once again, thank you so much for giving this webinar. It was a really interesting and wonderful talk. So yep, and as Seth mentioned, you can hit him on the Malcolm Slack. Again, on the Zeek Slack as well, we also hang out there. So if you have any questions, in general, any questions, just reach out to us in that Slack channel. We would be more than happy to answer any questions you have in general. So thank you so much, everyone, for joining this webinar, and hope you guys have a wonderful rest of the day.